All right. Hi everybody. So welcome to all of you. My name is Alex. I'm from Be My App. So I'm organizing this webinar with Zamir from Intel. So we will spend an hour together to answer your question regarding the Intel RealSense App challenge. So we guess you have many questions regarding the technologies. So Zamir is here to help you and to support you on that. So what we're gonna do, so I can see all of you in the attendees list. Okay, so once you have a question, just raise your hand on the attendees dashboard. And then we will try to go one by one, okay, and answer your questions. So for your information, this session is also in recording mode, okay. So we will add it online on YouTube after the session, and you will be able to watch it later on. Okay. So Zamir, do you want to introduce yourself?
Yes. Hi everyone. My name is Nadav Zamir. I'm from the Advanced Technologies team in Israel. We are in charge of pathfinding and prototyping, and mostly in the fields of computer vision. We currently handle the RealSense technologies, and yeah, I'm here to give you the session. As hope you will enjoy it.
All right. So basically, I saw that we already have a first question from Leon. So Leon, I'm going to unmute yourself, then you will be able to enter the discussion, okay? Please, for everybody, it's really important to have a good audio setup, okay? So be sure that you are in a closed room with no noise around you, and that you have a good mic, and then we can hear you well once you take once you are going to ask the questions. Okay, so Leon, I'm going to unmute you right now, and then you will be able to ask your question. Hi, Leon. Leon, can you hear us? Leon, are you here with us? All right. Okay. So yeah, for instance, keep in mind that yeah, to have a good connection and keep your audio connected. Leon, I'll let you fix your issues, and we will get back to you afterwards. So Zamir, maybe do you want to show a few slides, maybe as an introduction?
All right. Can you mute?
Yes. So I've just
all right.
muted.
Perfect. So all right. If any of you has a question, if you can't manage to interact, there is also a chat on the side. So we'll try to have a look at it. All right. Let's get started then. So just a quick look about our agenda for today. We have a lot to cover. We have 1 hour. I'm pretty sure we won't manage to cover everything, but I will do my best to give you the best hang of it. So what I'm going to go through is, first of all, introduce you to the RealSense technologies. I don't know how many of you are familiar with it, how many aren't. We're going to talk a little bit about the RealSense SDK, and then I'm going to show you how we create immersive experiences with this SDK. How we combine the digital world with the real world. We use a lot of augmented reality, and how we then move from single user interaction to multi-user interaction, collaborative gaming. And if we have time, I'm going to talk about Unity Toolkit. About the Unity toolkit, I don't know how many of you are familiar with Unity, so this we'll have to figure out then how deep I will go into it. All right, let's get started then. So first of all, I want to talk to you a little bit about the interfaces. The interfaces of computer devices, they evolved very little in the past 30 years. And in the beginning, we talked about keyboard, about mouse. These weren't really intuitive devices. People, when you got to the keyboard, when you got to a keyboard the first time, it's not like you knew how to use the keyboard. You had to be taught how to use it. The same goes for the mouse. However, then we moved towards touch interfaces, which were a bit more intuitive. You reach your hand, you touch it, it becomes more natural to you. Now we look about RealSense technologies, we look about what comes next, and we talk about actually interacting with your hands, interacting the same way you interact with people. So this is basically the RealSense goal, is bringing senses into the compute devices. And talking to him, interacting with him like you interact with any other person, either with your hands, with your speech. So in order to do that, Intel has developed the 3D depth camera. It started in 2013 with the creative camera that you can see right here. Now this camera was started as a peripheral camera and was for early developers. It was released along with the RealSense SDK 2013. Just recently, we released the 2014 RealSense SDK, which is very different from the 2013, and it supports the RealSense depth camera, the one you already have. And this camera is very thin, very light. It's going to be embedded into computer devices, either into all-in-ones, into two-in-ones, into tablets. And the major difference. Well, let's talk a little bit first of all about this camera. What are its features? Well, this camera supports either the length of 20 centimeters to 120 centimeters, and as I mentioned, it is very light. Because usually when I start telling people about this camera, the first question I have, hello, can you hear me? Seems like I've been disconnected. If anyone can hear me, can you say something on the chat? All right, perfect. So I see there are questions. I'll finish this slide and I'll start answering questions. So what I'm saying is that the main difference between this camera to Kinect, and this is usually what people hear me, what people are asking me for the first time, is, well, they're both 3D depth cameras, that's correct, but this camera is actually aimed for close range interactions. And this is one major difference. The other major difference is also the matter of power consumption. We're talking about something that's going to go mobile, and it's very light, very thin. So I see we have a question from Murthy. Let's see if I can manage to unmute. There we go. Murthy, I can hear you. Hello? Can you hear me? Any questions?
We can hear you well, huh, Zamir?
No, I thought there was a question. I saw someone raising his hand. Okay, let's continue. So the SDK itself speaks on four basic types of inputs. First of all, we're talking about the hands. We're talking about hand gestures. We're talking about 22 landmarks on the point of the hand. I'm going to show you in a moment how does it look. I don't know how many of you managed to play with it a little bit. And we're talking about the joints. We're talking about fingertips. Gestures can be either static or dynamic gestures. The second thing is the speech. Either it's text-to-speech or voice recognition, dictation mode, or command and control. The third one is the face. We're talking about 78 landmarks on the face. That's a lot of landmarks. We're talking about pose estimation, about emotions, whether the person is smiling, expressions, I'm sorry, whether the person is smiling, whether he's sad, surprised. And the last one is the environment. the environment is a very important part in understanding the person, because in order to understand the person correctly, you have to understand him in the right context. Meaning the gestures I'm making in front of you might be different than the gesture like I told when I'm alone. And the same goes for my voice, my tone of speech. And so when I'm talking about environment, we can have a look here just about like a small list of capabilities. You can see we have, for example, 3D object recognition, 2D object recognition and tracking. Scene perception is something that will be entering soon to the SDK. And so forth, augmented reality capabilities, including occlusion support. All right, so I want to talk to you now a little bit about creating augmented experiences. I'm going to start with immersive storytelling. When we started this concept of immersive storytelling, we actually thought about the basics of storytelling as it was at the moment. So you've had the book. People could start reading the book and they would either be engaged in the book or not. They would read the book and they say, this book interests me, or it's not interesting for me. But this book is static. It cannot change according to the person. This is exactly what we came to ask. Why can't we change the book and have the person being more immersed in the book, in the story itself? So this is exactly what we came to do. And I'm going to show you a quick video of it. I've heard it might be a bit of a lag, and you have to forgive me with it. But just before that, I want to show you a little bit about the camera capabilities. So let's have a look, first of all, at the hands tracking. So here you can see the depth video, and you can see my hands. You can see how I can recognize the joint on my hand. If I can put two of my hands, you can see that. I can select a certain gesture, let's say a fist. So when I show my hand and I close it, you can see it says down there a fist was detected. And I can basically play with it. You can see it's very robust. And there's a major difference, by the way, between the place where you can do detection to tracking. If we're talking about a farther distance, you can only do tracking, but it's harder to detect the hand here. If I'm removing my hand and I show it to the first time, maybe a bit farther, it won't track it. So let's have a look about the face tracking. And there we go. So you can see basically 78 landmarks on my face. You can see here the expressions I'm making. If I'm smiling, if I'm surprised, you can see how the expressions change. They provide you a value between 0 to 100. And you can see how the tracking changes. And I'm going to show you that a bit more later on, and how we use it for different capabilities. So I can either show you more examples, but I don't want to waste our time about it because I know you all have the camera. You can all play with it and see some more stuff by yourself. What I want to show you right now is something very small we made last year, which is called AR Book. Like I said, we're talking about immersive experience. I'm going to breeze through this. Maybe I should make it. The noise is not that important right now. So basically what we did is took an actual book, and on this book we embedded a tracking device, and we connected, we embedded tracking on a 2D tracking. And then we created a butterfly. Once you show the book to the camera, you can see the butterfly coming up, and you can play with it. So let's pause it for a second because I can see we have a question. All right, so yes, questions? Alex?
Basically, Sebastian is asking, could you explain a bit more about the hardware, especially the ID cam, in particular the parameters, filter option, and accuracy?
So wait, I see I'm having, let me stop showing my webcam. I'm sorry about that, so I can hear you better. Can you repeat the question, please?
Yes, so basically Sebastian is asking a question, which is, could you explain a bit more about the hardware, especially the IV cam, the parameter filter option, and accuracy.
All right. So first of all, the hardware itself, as far as we're concerned, we're talking about time-of-flight technologies. For those of you who are familiar with 3D photography, so the IV cam is based on the time-of-flight technology. For those of you who are less familiar, we're talking about the camera that emits a certain signal and measures how much time it takes the signal to hit an object and comes back. And this is how it can calculate the distance of that object from the camera. Regarding the accuracy, so the official accuracy, let's say the officially stated accuracy is 4 centimeters, I think. But I can, to be honest, until I can tell you that it's all a matter of your environment. I mean, this is very dependent on whether you're inside or outside. If you have something that is reflective behind you, if you have interferences around you, if you have some other devices that use infrared, for example. And also there's a matter of angles. Let's say if you're talking about the hand tracking, you can see that accuracy is very you have a lot of accuracy when your hand is straight in front of the camera, but once you get to a position where it's very hard for the camera to estimate, to actually see the hands or the fingers, it starts to estimate or guess what the finger's position, and then you obviously lose accuracy. So I hope that answers your question.
Right.
I'll continue the video. So just to show, I'm sorry?
Yes, Zamir, so there is also another question from Ulysse. Basically, I was wondering, can you see the dashboard question? The question dashboard on your leaderboard? Maybe.
Yes.
Okay.
Let's see.
So basically, you can see that Ulysse is also asking a question, which is, does the swipe gesture really works fine with the new SDK?
All right, now I can see.
Okay, great.
Does the swipe gesture really works fine with the new SDK? The detection seems to be really tricky. It seems to work randomly. Well, the swipe gesture, my experience with the swipe gesture is yes, it works pretty well with the SDK. And as far as the detection goes, it actually works even better. I would, let's say, if you are having problems with a swipe, which is a dynamic gesture, if you're talking about the detection of the hand itself, so the detection works pretty well. Like I said, there is a matter of distance from the camera, but as much as I experienced it so far, we've had a really good experience with the detections of the hands. I know there has been a small problem with a small issue, maybe with like hands for children, but I think this is something they're working on, and I'm not sure if it was resolved already or not. But I think there was a bit of a small confusion. But other than that, it's supposed to be working pretty well, yes. And all right, let's see if there's any.
Yes, basically, so we have Ruti who has a question. Ruti, can you hear us?
Mm-hmm.
No, so basically, I'm going
So
to...
I can see the question itself, and
yes.
it says, would the presence of mobile devices or mobile towers nearby will affect the camera in any way? And the answer is absolutely not. There is no reason for it to affect it, unless there is, I don't know, like I said, a reflective screen behind you. And I'm not talking about a small screen like a phone or a tablet. I'm talking about something that is being held straight in front of the camera. So you shouldn't be having any experiences from that has to do with mobile devices or towers. And as for Sebastian's question, you would like to know more about the parameters in the SDK, talking about smooth aggressiveness. So as far as the parameters goes, I wouldn't get in too much into the parameters because I think it might be a bit of a waste of our time. What I would want to say is that there is a smoothing model inside the SDK that was provided along with it. It provides different types of smoothing. The best thing to do is basically play with it. You can actually have inside the documentation, you can see a lot of different aspects of it. Once I go into the Unity toolkit, if I manage to reach into it, I don't know how many of you people are developing in Unity, but the Unity toolkit is meant to provide drag and drop capabilities of the capabilities of the SDK inside the Unity environment. It's basically to help the Unity developers keep on using their own Unity language without getting into the SDK itself.
Okay,
so I can see there are a lot of questions. Maybe it's a good idea if we will hold the questions for a moment and continue for a while.
Yeah,
and
good.
I'll keep answering questions because I can see otherwise we really won't have the time to do anything.
Great.
So I think if you have questions that are relevant to what I'm presenting at the moment, this will be a good idea. If not, maybe you should try and keep them towards the end, and I will try to leave about 15 minutes for questions in general. So yes, the video was paused. So just as I'm continuing now the video, you can see basically how we use 2D tracking, and we also have, let's say, face tracking, or we use the 3D depth. Here you can see the face tracking, and if you have several users here in front of the camera, it will track each user, different users. And in this scene, I'm sorry, you can see how we put the person inside the book. It's basically having an immersive experience, having the person integrating with the book. So I can go on with it. Maybe I'll just show you the last scene, which was what we call a virtual world into a window into the virtual world, where we use the book itself as a window, and we can move it around and have a look in the virtual world. And we can look at it from different angles. Of course, it has it depends on the angle of the camera, and so forth. So let's continue the presentation. As I was saying, what we're talking about RealSense, we're talking about a 3D world. So if the instance technology, what it comes to do is basically take the people outside their 2D screens into the 3D world, because we think that the 3D world is much more interesting for the people. It's a lot more appealing for the senses. And I'm sure you're all aware of a problem where you have about this situation. We have a lot of people sitting in a restaurant. Each person actually holds their own phone or tablet and looking at it instead of interacting with each other. And this is another thing we come to solve, or basically to handle. And in order to do that, we look at it in two aspects. We look at it in the matter of augmented reality, and we look at it in the matter of collaboration. So in the next demos I want to show you is how we take the virtual world and basically bring it back into the real world. So in order to do that, we use, let's have a look here. So I will show you two small videos. The first thing is in this video I want to show you how we take the virtual world and bring it back into the real world. And to do that, we use the depth camera. Using the depth camera, we can understand the surface of the table. We can understand that there are objects on the table. You will see later how we add objects to the table and interact with them. So now you can see how the farm is coming out on our table. And the view is basically the view that you get to see from your tablet or from your PC. I will move a bit fast forward, and you can see how the Uncle Jeff comes out from the farm back into the table and actually interacts with it. Now I want to I will stop it because I want to show you the second video, which starts here. So in this point, we want to show how we can interact with external elements, external objects, and the virtual objects. So first of all, you can see Jeff and the sheep walking on the table. You can see how we understand that there is a table. We can understand the limits. You can see how the grass stops just at the end of the table. And now we want to basically have Uncle Jeff here go up on the ramp and save the sheep that is being stuck up on the island. So we put this ramp, this is a real ramp, and you can see how we can understand that there is a ramp there. And this is being done using the depth camera, and then we can bring Uncle Jeff all the way up there. And another small sample for it, well, you can see, for example, the snow that piles up on the ramp. So let's show this another small scene. Here you can basically see an interaction of a tractor. You can see how the tractor understands the ramp and climbs on it. Because we used Unity, we also use a physical engine, so you can see how it is harder for him to climb up. And once he climbs up, it will be easier for him to climb down. So this is, again, being done based on the depth camera. As for being available online, these samples are not available online. Some of them are, some of them aren't. The Unity samples I will show later are available online, but these specific ones are not. I want to show you another small sample of augmented reality interactions, which what we call an AR pet. I think the name is pretty much self-explanatory. In the first scene, we show how the camera basically perceives the 3D depth interaction. You can see an occlusion. You can see how the hands hide the ball once they come on the other side of it. And you can see how we can go with the hands back and forth inside. And I will answer the question just in a second. The next thing I want to show is how we have an AR pet. So our AR pet will be a small dragon. And you can see how, first of all, we can move our hand, interact with different parts of the scene. And in this small egg over there is a dragon. Once we break the egg, you can see the dragon coming out. And now we can play with it with our hands. We can push him. We can hold him. We can close our hands, and there's this little magic where he starts firing stuff. When we attack him, we can hide him. So this is another example how we take augmented reality, but this time we take ourselves and put ourselves inside the virtual world, or we take the virtual world, as you've seen in Uncle Jeff, and bring him into the outer world. I can't really understand with his question about did we have to program to make Uncle Jeff climb on the ramp. What we basically did over there is build a 3D mesh of the entire scene using the depth camera, using the depth data. And based on the, let's stop this video. Based on the depth data, we basically we understood that there is another object over there, not necessarily a ramp. This is something that I will show in a moment, how we can understand that this is specifically a ramp. But in this demo that I demonstrated, we didn't understand this was a ramp. We understand that there is, let's say, a certain object that goes in a certain way, and Uncle Jeff can either climb on it or not, depending on the physical engine. So the elements what you've basically seen so far is how we can interact with the virtual world, how the virtual world can interact with us. And as I said, we use a lot of augmented reality. But this was done in a very small scale. And as I was saying, in the demos before, we didn't necessarily understand that there was a ramp. We understand that there is something, but not necessarily a ramp. The next thing I want to show you is how we use object recognition capabilities in order to actually interact with objects, with real objects, and augment these real objects. So for this purpose, we created a small demo we called AR Kit, Augmented Reality Kit. And here you can see how we recognize that there is a dragon. Once we press the dragon, you can see how a fire comes out of the dragon. And in a moment here, you can see how we add a tree into the scene. We recognize there's a dragon. We recognize there's a tree. We can fire and we can throw fire at the tree, and the tree will burn. At this moment, we can actually add a third element. This will be our fire truck, and you can see how we augment the fire truck. We add water, we add smoke that comes out from it, and the fire truck can turn the fire off. One last thing we actually added, which was pretty cute, is how we can, like I said, burn the tree. And if the fire truck does not come, so we can actually diminish the tree. We can remove it. Although the tree is really there, we hide it from the table. We hide it in the screen. So let's see a bit about the questions. I will say it out loud because I don't know how many of you can see them. So the first one was asking if you had placed a physical object, i.e. a ramp on the table, and Uncle Jeff automatically detected it and climbed up onto it. So not exactly true. Uncle Jeff didn't really walk into it automatically. He walked to it because we pressed and told him to walk to it with the arrows. In this demo, the controller was the arrows, but this can be any other. This can be done automatically. That there is something that you can put something and it can recognize that it is there. As I've just showed, you can recognize actually what this object is, or you can recognize in general that an object was added into the scene. So as for Sebastian's question, are there any plans for supporting other OSs like Linux, for example? Yes, there are, but as I was saying, this is very yes, there are plans. They are working on it, not at the moment. We have another small question. Can you bring us another example of a swing gesture, please? So let's try and keep it to the end. What will happen if the fingerprints go near the dragon and the dragon releases fire and the engine releases water? I don't really understand this question. If the fire range goes near the dragon. Well, basically, Ruthie, the entire point with this demo that you see here is a matter of how you plan it, how you choose the interactions, and how you. So we chose the interactions that once you show the dragon and you press on the dragon on the screen, the dragon starts firing. And we decided that the tree will go on fire when this happens. So you can actually play with it and do a lot of things with it. This is very. This can be done in any other way. Let's continue. So the next thing I want to show you, what I want to talk to you is, when I started this talk, I actually talked about creating an intuitive experience, an immersive experience, and I've mentioned how people are being captured in their 2D screens instead of coming out into their 3D screens, and how we lose interactions between people and humans. And so far what I've shown you is how we can interact in a very small environment. How can one person interact either on its table or with his small toys? But what we want to go through, our next step to take it, is to move from small-scale interaction into a large-scale interaction. So when I'm talking about large-scale, I'm talking about room interaction, room-size interaction. And the second thing I actually want to go through is how we move from one person's interaction to a collaborative interaction, to several people interacting together. So I want to show you two samples, two demos of, the first thing I want to show you is the collaborative interaction. So in this demo we took again our Uncle Jeff, and here we have the same thing, the farm coming out on the table, but this time we have two tablets holding the cameras at the same time. I will breeze through forward just to save you your time. But the point is now creating a world together. So once the farm comes out to life and the grass coming out, each person who holds the tablet can actually plant a tree on different places on the table. And the two tablets can see, they both see the same scene together from each one from its own point of view. So if now Barak here putting trees all over the table, I can see the trees as well. And if I will put trees and or sheep, which I can do later on, you can see the trees I'm putting down there in the back popping up, and we can put sheep and play with them together. The next thing we can also let's have a look around. We can throw tomatoes at the table, and you can see how Barak can see the tomatoes being thrown straight from me, and they can hit the table and jump and bounce on it. And the reason this can happen is because A, we have a collaborative interface. We both can see the same scene. We have a 3D understanding of the world. And because we can understand that this is a table, we can understand that there is a surface over there, we can throw the tomatoes and they can hit the surface and bounce out of it. I think we also used here at a certain point an object recognition. Let's have a quick look if, yeah. So here we put a chest and a tractor, the same tractor as before. And using the object recognition, we hide the chest in a virtual chest. We put a virtual chest above this real chest, and same goes with the tractor. Now this is just a concept video. As I was saying, you can take it to many places. This is just to open your mind. I see we have a pile of questions here, so let's see what's going on here. So can you submit the early demos? Well, guys, anything, try to keep your questions about the presentation. I'm having really hard time bouncing between general questions and questions about the presentation. If you have general questions, either about how you submitted your early demos or anything that has to do with generally about the SDK, let's try to keep it to the last 15 minutes. So about demos about 3D scanning and reconstruction. Yeah, do we have anyone?
Basically, yeah. What I'm gonna do during this question and answer, I'm going to share a few polls. Then you will be able to know, a bit about your audience. Okay, so I'm gonna take like 2 minutes. Then people can answer quickly to the polls, and then you can continue chatting.
All right.
Okay. Then you were asking about Unity developers, so yeah, I think it's good to know if people are familiar with Unity. For you, Zamir?
Yeah. I think this is actually I would love to know if how many of you are interested. I will maybe skip some parts and get faster to the Unity part, just because if you want me to show you, to introduce you into the Unity part, so maybe I can actually put more emphasis on this part. I don't know how many of you, like I said, developing on Unity.
All right. So right now we have approximately 60% of the audience that never developed a project with Unity. So it's like half. So maybe you can, yeah.
All right. So I will keep on going as well, and I will give a small introduction. Just bear in mind that you have everything in the documentation as well. So don't worry about that. I will breeze through the questions again. So as I was saying about 3D scanning and reconstruction, I do not have a demo for it at the moment, so I cannot show it. But this is basically more of a world-facing and less than a user-facing demo. It wasn't really meant for the IVCam camera. I didn't really understand the question of Sodipto, of how are they connected. How the tablets are connected. Yeah, so they're connected through Wi-Fi. The connection is being done. The collaboration farm is being done through Wi-Fi. How many people can the camera track simultaneously? Well, I'm not sure about the exact number, but it can be pretty, I think it can be more than somewhere around 8 or 10 people. We're talking about face tracking. If you're talking about hand tracking, the number changes as well. You can actually have a look at it in the documentation. So let's have a look. Did you already receive your Intel RealSense camera? No. Right, let's see. So I've showed you some collaboration, and I want to show you another demo of collaboration, but this time, as I was saying, we moved from a small scale to a large scale. So this is, bear in mind, as I was saying, a small, like a demo. This was done for as a concept, just of what you can basically do with the camera. And let's have a quick look here. I will try to give a short explanation of what's going on here. So the idea here is how we can have 3 cameras. As you can see, we use here the creative camera, the previous camera. And we fly a ship in the room, in the actual room, using the 3D depth camera, using the gestures. So you have a pilot and you have 2 people holding their devices, and they actually can see the ship flying in the room itself, and each one can see it from its own point of view. And we're talking here about large-scale interactions. I was saying we're talking about a ship that flies in the entire room. And we're talking about 3 people interacting with it. 2 people are actually, at the moment they're viewing, but in the moment you can see the actual interaction. And the third person is actually flying the ship around in the room. When we get to the interaction part, you can see dragons coming and attacking the ship, and the 3 people are trying to defend the ship. The pilot, which is me, trying to fly the ship around and fly away from the dragons, and the 2 people holding their devices, they can shoot fireballs at dragons. And each person can actually see the other person shooting fireballs at dragons and killing the dragons. As I was saying, it's one scene, and they all experience it from their own point of view, from their own place. All right, so we can stop that part. As for the max distance from which a person could interact with the farm on the table, well, that depends a lot on your camera, and that depends on the light in the room, and this is something you have to play with. As I was saying, we're talking about, basically, I would estimate about a meter if we're talking about an A4 marker, about somewhere a meter and a half. So is it tracking data from the? I'm answering another question. So the question is the tracking data from the camera shared across the 2 tablets over the Wi-Fi connection you mentioned? Well, yes. Each person is actually each device can understand his own location in the room, and he shares only the location, his location in the room, versus a global system. So let's go on. As I was saying about the UV map, I will answer later because this is a very general question. So like I was saying, so far we're talking about a human. We're moving from a human-computer interaction to a human-world interaction, and just want to have a look. We have about 5 more minutes before we move to the questions. 5 to 10 minutes, all right? So I'll try and move a bit faster. So I was talking about how we move from one user interaction to collaborative interaction, and how you can basically sync the 2 devices. This can be done in numerous ways. You don't have to. What we've done here in the demos you've seen so far, we used Unity and the Unity server, but this is not necessarily the way you need to sync it, obviously. However, we have used a 3D marker in order to get each person's location in the room. I'm sorry, a 2D marker. So if you, I know that the SDK is planned to support, as I was saying, scene perception, which will allow you to do a markerless tracking and localization. This is not available at the moment. Let's continue. So we're talking about we want to interact with, like I said, interact with the story collaboratively. I'm not going to waste our time. So the challenges that comes along with these devices are obviously, we're talking about battery power, responsiveness of device. We're talking about robustness of platforms. And this is exactly interest in creating and developing these cameras, because this pushes people to get new devices. We're talking about the next generation of devices will have to handle a lot more data, a lot more information flowing. We're talking about 3D, so this means 3 times the information. And let's breeze through the Unity toolkit just before we get into the questions. So first of all, for those of you who are not familiar with Unity, I'm going to give a quick view of Unity. Let's have a look here. Just a second. There we go. So for those of you who are not familiar with Unity, just so you will have a very small concept of where we are and what we're doing. Unity is a platform for game developers. It's a very successful one. And what we were trying to do is actually have all these capabilities that you've seen so far, have them being more available to the game developers. So the Unity basically looks somewhat like this. You have here the game view. This is what the players are viewing. You have here the scene view. This is the place where you can actually see this is where you can plan your world and handle it. And here you have all sorts of libraries, hierarchies, and you have the samples and you have all sorts of prefabs and so forth. So I'm going to start with an empty scene, just to give you a concept of how easy it is to create a new scene and how easy it is to add RealSense capabilities into your Unity game. So this is an empty scene. What I'm going to do is basically add to it a directional light, so we can see something. We're going to add a cube and put it on the zeros. And let's make it a bit larger. And I will rotate it a little bit so you can have a 3D view of it. There we go. So far I haven't done anything. And now the RealSense, basically, let's make it a bit more so you can view it. Once you add the RealSense toolkit into Unity, you can have this, what you will get is this folder here along with the plugins as well. In this folder, you can have several things. I will go through very, very quickly about them, but you can get a lot more information through the documentation. The actions are the main core, the main scripts. Unity works in a matter of scripts, where you drag and drop into the objects, let's say the cube. So in order to add, let's say, a tracking capability into this cube, I have here a tracking action, where you can see right here. And I can grab this tracking action and throw it on our cube. And here now you can see along through the rest of the parameters of the cube, you can just see as well the tracking action. I don't have to do much. I can only press play now, and the camera will open. I don't know how many of you are how much you're capable of seeing that, but if you can see now that I'm moving my hand, well, you will have to believe me about that. And you can see the cube tracking my hand. So maybe I can share let's have a look. Can you see me right now? I hope so. So you can see, let's open the Unity. All right, so you can see how I move my hand, and you can see how the cube tracks it. Now we're talking about orientation in space. We're talking about right, left, back and forth, the entire hand orientation. We're talking about the location as well. And now in very simple steps, I can change it from tracking my face, tracking my hands, into tracking either my face or to tracking a certain object. Let's say if I put it on my face and I press a play, so you can now see how the cube will track my face as well. There we go. You can see how when I go back and forth, the cube tracks. I can move back, right and left. And you have a lot of parameters there you can play with. You can have smoothing factor, as I mentioned. You can play with the virtual box. I mean, what you want, you can define a certain area you want object to run in. You can invert the axis, you can constrain, you can stop a certain axis from the cube from moving in a certain axis. in one axis or another. So we have basically a lot of capabilities there. Let's do that for a second. I'm going to just show you, to give you a small concept, I'm going to go through the actions themselves. You have a translation action, which means you can grab an object with your hand and move from one place to another. A tracking can actually track your face. A rotation action and everything, like I said, is available in the documentation. Sorry. Everything is available in documentation, like a lot more explanations. I'm sorry, I'm going through it very, very fast because we really don't have time, and I want to leave some time for questions. But you basically have a lot of capabilities over there. You have send message for those of you who are more familiar with Unity. You can actually throw the raw data and play with it and do with it different stuff. And the platform of the Unity toolkit itself is built in a way that it is extendable. We're talking about an open source code. Everything is open. You can see everything. You can change everything. And it is built in order to make it for you easy to change things and to build your own stuff, your own action based on the SDK and based on the data without having to interact, having to dive into actually writing SDK code. So I want to show you a few samples of what basically you can do with the Unity toolkit. Let's see, for example, the AR mirror. So here what we basically did is we used the tracking action. And in order to do that, we just took the face and we put some objects and told them to track the face. We took the hands, we took some objects, told them to track the hands. So you can see how now we have objects tracking me, tracking my face. If I'll show my hand, you can